Vector Algebra. Introduction. Displacement. Displacement is a straight line segment going from one point to another. Displacement have direction and magnitude. Such quantities are called vectors. Examples: velocity, acceleration, force, momentum, etc. These quantities has magnitude and direction. The quantities having magnitude but no direction are called scalars. Example: mass, charge, density, and temperature. Now, representation of vectors. Vectors are represented by bold letters. Ordinary letters or italic letters are generally used to represent scalars. Magnitude of a vector is written like this or simply italic A. Now, a vector minus A is a vector with the same magnitude but opposite to the direction that of A. Minus A is a vector with the same magnitude as A but opposite direction. Vector operations. There are 4 types of vector operations, 1 addition and 3 types of multiplication. The first one, addition of 2 vectors, multiplication by a scalar, dot product of 2 vectors, cross product of 2 vectors. These are the 1 addition and 3 kind of multiplication. First one, addition of 2 vectors. This is the vector A and it is the vector B, and A plus B is denoted like this. If you want to add 2 vectors A and B, then place the tail of B at the end of A. This is the tail of B that should be kept at the end of A. Then A plus B is a vector from tail of A to the end of B. So that's it. If you want to add 2 vectors A and B, then we need to keep the tail of B at the head of A. Then the sum A plus B is the vector from tail of A to the head of B. Now, some properties of addition. Addition is commutative. That means A plus B is equal to B plus A. Addition is associative. A plus B plus C equal to A plus B plus C. In order to subtract a vector, add its opposite. That means we need to subtract the vector B from A, then add minus B to A. That means A minus B is equal to A plus of minus B. Multiplication by a scalar. This is the vector A that is multiplied by a scalar 2. So this is the vector 2A. A positive scalar A multiplies the magnitude but leaves the direction unchanged. Both the vector A and 2A has same direction, but 2A has double the magnitude of A. If A is negative, the direction will be reversed. Scalar multiplication is distributive. That is, A into A plus B equal to A into A plus A into B. This is the distributive property. A dot product of 2 vectors. A and B are 2 vectors inclined by an angle theta. Then, dot product of the vectors is defined by A dot B equal to AB cos theta. Now, A dot B is a scalar, so it is called scalar product. If you are taking a dot product of 2 vectors, the product will be scalar, so dot product is also known as scalar product. Now, let us discuss some properties of dot product. Dot product is commutative, that is, A dot B equal to B dot A. Dot product is distributive, that is, A dot B plus C equal to A dot B plus A dot C. A dot B plus C equal to A dot B plus A dot C. If the 2 vectors are parallel, then A dot B can be written as A dot B equal to AB cos theta. As the 2 vectors are parallel, theta equal to 0, so that is equal to AB cos 0. Cos 0 equal to 1. So A dot B is equal to AB. That is, if the two vectors are parallel, then vector A dot B equal to AB. For a vector A dot A equal to A square. If the two vectors are perpendicular, then theta equal to 90 degree. That is, A dot B equal to AB cos 90. We know that cos 90 is equal to 0. So A dot B equal to 0. Let us discuss an example. Let C equal to A minus B. Calculate the dot product of C with itself. So it's given that vector C equal to vector A minus vector B. Now we need to find vector C dot C. So it's a diagram of the equation C equal to A minus B. Solution. We have the value of C that is equal to A minus B. Now we need to find C dot C. Then we can substitute the value of A minus B here. That is C dot C equal to, instead of one C we can substitute A minus B, and instead of second C we can substitute A minus B. A minus B dot A minus B. This can be written as A dot A minus A dot B minus B dot A minus into minus plus B dot B. So this is the equation. We know that A dot A equal to A square, B dot B equal to B square. Also we know A dot B equal to B dot A. So first term will be A square and last term will be B square. The middle term will be minus A dot B minus A dot B, or minus 2A dot B, or minus 2AB cos theta. So C square equal to A square plus B square minus 2AB cos theta. It is the law of cosines. Cross product of two vectors. Cross product of two vectors is given by A cross B is defined as AB sin theta n cap, where n cap is the unit vector perpendicular to A and B. The result of A cross B is also a vector, or A cross B is also a vector, and hence cross product is also known as vector product. The direction of the cross product A cross B can be found by different methods like right hand screw rule, right hand rule, etc. Let the fingers point in the direction of first vector and curl around toward the second, then your thumb indicates the direction of cross product. For example, if C equal to A cross B, we need to find the direction of C. Then let your fingers point in the direction of A and curl around towards B. Then thumb indicates the direction of C, which is equal to A cross B. In this diagram, A cross B point into the page, B cross A point out of the page. Cross product is distributive. That is, A cross B plus C equal to A cross B plus A cross C. It's not commutative. That is, B cross A is equal to minus A cross B. If the two vectors are parallel, their cross product is 0. For a vector A cross A equal to 0. This result 0 is a vector. It is the 0 vector, which means a vector with a magnitude is equal to 0.